everyone, we are the Group 1 and our topic is all about minerals and rocks. Reporters, I am the leader, Miss Banwag, and I am with Mr. Bachansila, Mr. Baltar, Miss Badang, and Mr. Buhara. First of all, what is a mineral? Or what is mineral? A mineral is a homogeneous, naturally occurring substance formed through geological process that has a characteristics chemical composition, a highly ordered atomic structure, and specific physical properties. So, a mineral is a naturally occurring inorganic substance which has a definite chemical composition, normally uniform throughout its volume. So, in contrast, rocks are collections of one or more minerals. In order to understand how rocks vary in composition and properties, it is necessary to know that the variety of the minerals that commonly occur in them. So, and to identify a rock, it is necessary to know which minerals are present in it. So, minerals are made of elements. So, the eight common elements composed of 98% continental crust rocks. So, some minerals like quartz are composed of just 2 elements. Others, like amphibole, are made up of several elements. Some elements occur more frequently than others. So, minerals, for example, the quartz here in the table, it has 2 elements, which are the oxygen and silicon. Hill and feldspar, it has oxygen, silicon, aluminum, calcium, sodium, and potassium. In mica, oxygen, silicon, aluminum, iron, potassium, and magnesium. In amphibole, oxygen, silicon, aluminum, iron, calcium, and magnesium. So here in physical properties, the color of a mineral when it is powdered is called the streak of the mineral. So the streak is the color of the powdered mineral. This is most readily seen by scraping the mineral across a plate or unglazed hard porcelain and observing the color of any mark left. It is diagnostic property of many ore minerals. For example, the lead or galena has a metallic gray color but a black streak. So here in the color of the mineral is that seen on its surface by the naked eye. It may depend on the impurities present in the light-colored minerals, and one mineral specimen may even show gradation of color or different colors. For these reasons, color is usually a general rather than a specific guide to which mineral is present. So next, here in the luster of a mineral is the way its surface reflects light. So, light is reflected from the surface of the mineral. The amount of light depending on physical qualities of the surface, such as its smoothness and transparency. This property is called the luster of the mineral. So, and it is described according to the degree of brightness from splendent to dull. So next, mineral characteristics. So the color, minerals have characteristics colors. So dark minerals, black, brown, dark green. For example, the olivine, amphibole, pyroxene, biotite, mica. So while the light minerals are white, gray, pink. So for example, the quartz, feldspar, the muscovite, the mica, and the calcite. So careful, some minerals have many colors. Next slide. So, crystal form. The arrangement of the faces of the crystal to form a particular shape. So, these are the common shapes: prisms, pyramids, needles, cubes, and sheets. So, as you can see on the screen or on the slide, pyramids of calcite. So, this is the example in the picture, and the needles of tourmaline. So, transparency is a measure of how clearly an object can be seen through a crystal. So, next slide. Hardness. So, minerals ranked by their relative hardness using Mohs hardness scale. So, harder mineral can scratch softer minerals. So, soft minerals naman are more likely to break down at Earth's surface. So, more resistant minerals more likely to be preserved like quartz sand on beaches. So, here in hardness, the relative hardness of two minerals is defined by scratching each with the other and seeing which one is gauged. So it is defined by an arbitrary scale of 10 standard minerals arranged in Mohs scale of hardness and numbered in degrees of increasing hardness from 1 to 10. So let's now proceed to the next reporter.
Good day everyone, I am Earl Brian J. Bachansila, second year engineering student, reporting about minerals. So as we all know, minerals are naturally occurring inorganic substances that have a definite chemical composition, and those substances can be classified as minerals if, number 1, it should be a naturally formed substance, number 2, it should be an inorganic substance, number 3, it should be solid, number 4, it should have a specific chemical composition, and number 5, it should have a characteristic crystal structure. Now, let us proceed to minerals' properties or characteristics. The first one is the cleavage. The cleavage is a way a mineral breaks, and breaking of minerals may differ depending on the directions defined by the atomic structure of a substance. Some minerals, such as quartz and garnet, possess no cleavages, whereas others may have one, or we can call it as mica, 2 or pyroxenes and amphiboles, 3 galena, or 4 fluorite. In this slide, the example is the mica, which forms sheets joined by weak ionic bonds, or it is the one set of cleavage planes. For the next slides, the examples given are feldspars and amphibole, which I have said earlier, it is the amphibole, who have two sets of cleavage planes. The feldspar has two cleavage planes that intersect at 90 degrees, while amphibole also has two cleavage planes, but they are not at the exact 90 degrees to each other. For the next slide, we have here the luster and the streak. Luster is how the light reflects from mineral, or the luster can be defined as the smoothness and transparency of a mineral, while the streak, it is the color of mark on unglazed porcelain, or it is the color of a mineral when it became powder. The streak can only be seen when the mineral became powder or when you scrape it on an unglazed porcelain. And for the next slide, which is the hardness. The hardness of two different minerals can be determined when you scrape both of them with each other. It is defined by an arbitrary scale of 10 standard minerals arranged in Mohs scale of hardness, and number in degrees of increasing hardness from 1 to 10. As we all can see here in the slide, the number 1 is the talc, which means that it is the softest mineral, while the number 10 is the diamond, which is, as we consider it as the hardest mineral. In the number 1, which is the talc, it is still possible to scratch, while the diamond is impossible to do so. For the next slide, which is the cleavage, as I have mentioned earlier, as the way a mineral breaks. The one direction, as we call it mica, two direction as feldspar, and three directions are as calcite. Now for the next characteristic or property, which is the fracture. Fracture, it is the surface that is broken which is not flat, that is obviously different from the cleavage planes. There is a curved, riffled fracture that is termed as conchoidal, or the shell-shaped fracture that you are seeing here on the slide. Fracture is kinda similar to cleavage, which is the breakage of minerals, but it is different in terms of the shape and the form, which how it breaks the minerals. And now for the last properties of the minerals, which is the heft. Heft is the weight of the mineral when it is held in our bare hand, or when we hold a mineral with our bare hands. It is an informal sense of density. And the taste, which is the definitive for halite, of course, but a few other evaporative minerals also have distinctive taste. Aside from halite or the rock salt, other minerals also have their own distinctive taste that differ them from any other minerals. Then next, we now have here the metallic ore minerals, which is one of the group in the non-silicate minerals. So metallic ore minerals in simpler terms is or are minerals that is high in metal content and can be of high value in terms of economic usage. If iron ores are present in large quantities or greater than 5% in aggregates from crushed igneous rocks, they may weather and discolor any concrete made from them. Magnetite is often present in large quantities in basic igneous rocks like basalts or dolerites, and its presence may affect electrical equipment and compasses. Just like what I have said, as the metallic ore is good for the economic usage, we have the native elements such as the copper, silver, or gold, like as we all know, is very high in value when it is being sold in the market or elsewhere. And on the next slide, we will see the non-metallic or non-silicate materials. The most common minerals in this group are calcite, carbonate, and gypsum, sulfate. All have white or colorless streaks. They are often found in veins together with metallic ores. In veins, such minerals, together with fluorite and barite, are called gangue minerals. In contrast to the metallic ores, calcite is an essential mineral in limestones and may be present in many sedimentary rocks as the cement matrix. It is the principal constituent of marble. Limestone deposits may be crushed to a fine powder and used as agricultural lime. The neutralizing value of any calcite limestone deposit must be known for this purpose. And in many regions, agricultural lime with a higher MgO content may be preferred. That is, the limestone will be composed of both calcite and dolomite. In many countries of the Middle East, limestone and are widespread and may be the only material available to use as a crushed rock aggregate for concrete or roads. Limestones are also the most important constituent in the manufacture of cement. These non-metallic minerals are minerals that lack metallic contents or characteristics, but can still be of good use and essential for many industries. Now for the next slide, let us proceed to the silicate minerals. So silicate minerals are minerals that are most abundant in the Earth's minerals, and they are quartz, feldspars, mica, amphibole, and many more. Silicate minerals are mainly composed of silicon and oxygen, then bond together with other cations to form the silicate minerals. These minerals also differ in colors. They have the dark colored silicate minerals and of course the light colored silicate minerals. For the dark colored silicate minerals, These minerals range from vitreous to dull in luster, and one of the minerals categorized in the dark-colored silicate minerals is the olivine. The mineral olivine is a magnesium iron silicate. It is a type of neosilicate or orthosilicate. While for the light-colored silicate minerals, the light-colored silicate minerals includes feldspar. Feldspars are a group of rock-forming aluminum tectosilicate minerals containing sodium, calcium, potassium, or barium. So that is all for my report. Thank you, and let us proceed to the next reporter.
Good day everyone, I am Edelgrace Padang and I'm gonna discuss about rock. So let's talk about rock. Well, a rock is a naturally occurring aggregates of minerals and other rock fragments. Rock is a natural substance composed of solid crystals of different minerals that have been fused together into a solid lump. And it doesn't matter if the minerals may or may not have been formed all the same time, but what matters is that the natural processes glue them all together. The nature and properties of a rock are determined by the minerals in it, especially those essential minerals which individually make up more than 95% of its volume. And an individual rock type or specimen is always described in terms of its mineral composition and its texture. So, technically speaking, we can really classify the rocks or what type of rock it is based on its mineral composition. So, as I am saying, rocks are made of minerals, right? And it's a 20 common minerals, and some of those minerals can be found in the rock granite, and those are the feldspar, quartz, mica, and amphibole. Rock classification. Well, rocks are commonly divided into three major classes according to the processes that resulted in their formation. And these classes are the igneous rock, the sedimentary rock, and the metamorphic rock. So let's talk about igneous rocks. Igneous rocks are formed when magma cools in the Earth's crust or lava cools in the ground surface or in the seabed. The size of crystals of minerals in igneous rock depends on rate of cooling of magma, because rapid cooling produces microscopic crystals, while slow cooling produces large visible crystals. And we can classify if it is a volcanic or plutonic rocks based on the size of the crystal, because in rapid cooling it produces volcanic rocks, while in slow cooling it produces plutonic rocks. So based on the size of the crystals, we can learn where the rocks had formed and what kind of igneous rocks it is. So in igneous rocks, silica-rich rocks are composed mainly of minerals quartz and feldspar, while in silica poor, it composed feldspar with iron and magnesium-rich minerals like amphibole, pyroxene, and olivine. So in igneous rocks, color varies with silica content composition. Silica-rich minerals such as quartz and feldspar are light-colored, while silica-poor minerals such as amphibole and biotite mica are dark-colored. So yeah, that's all, and next presenter please. Thank you.
I am the next reporter. My name is Alas Farbuhara. My topic is about texture of rocks, sedimentary rock, and types of sedimentary rocks. Texture refers to the physical appearance or character of a rock, such as grain size, shape, and arrangement. It is stated that igneous rocks that crystallize slowly beneath the Earth's surface typically have visible individual minerals, and extrusive igneous rocks tend to cool much more rapidly, though they cool much more rapidly and minerals grow quicker, but the minerals cannot get as large. Thus, they have a sugary or fine-grained texture. These are the four different types of rocks texture. The next slide is the mineralogic content of rocks. Felsic rock, with predominance of quartz, alkali feldspar, and feldspatoids. The felsic minerals. These rocks are usually light-colored and have low density. The given example here is granite. The next one is mafic rock, with predominance of mafic minerals, roxines, oliveness, and calcic plagioclase. These rocks are usually dark-colored, but not always, and have a higher density than felsic rock. The given example here is basalt. And the last is ultramafic rock, with more than 90% of mafic minerals. The example here is dunite. The next slide is sedimentary rocks. Sedimentary rocks are classified by the source of their sediments and are produced by one or more processes. So what is sediments? Sediment is a solid material that is moved and deposited in a new location. Sediment can consist of rocks and minerals as well as remains of plants and animals. Sediment moves from one place to another through process of erosion. The next slide is the types of sedimentary rocks. There are three types of sedimentary rocks. The first one is clastic, second one is chemical, and the third one is biochemical, identified by materials that make up the rock and the process by which they formed. The clastic sedimentary rocks is the most common type of sedimentary rock. It is composed of rock and mineral fragments. There are three stages of rock formations or formation of rocks. The first one is generation. The next one is transportation, and the last one is classification. Transportation is sediment can be transported by sliding down slopes, being picked up by wind, or by being carried away by running water in streams, rivers, or ocean currents. And the lissification is the process by which sediments combine to form sedimentary rocks. Next, sedimentary rocks form as horizontal layers or beds, identified based on composition and thickness. The oldest beds are at the bottom and the youngest are at the top. The fragments of older rocks that are composed in clastic sedimentary rocks are boulders greater than 25.6 centimeters, cobbles 6.4 to 25.6 centimeters, pebbles 2 millimeters to 6.4 centimeters, sand 1/16 millimeter to 2 millimeters, silt 1 of 256 millimeter to 1/16 millimeter, and clay less than 1/256 millimeter. Next slide. Chemical sedimentary rock and biochemical sedimentary rocks. Chemical sedimentary rocks are formed when minerals precipitate from a solution, usually seawater. Halite and gypsum are examples of minerals that precipitate from aqueous solution to form chemical sedimentary rocks. Biochemical sedimentary rocks are composed of accumulation of organic debris. Coal and some limestone are examples of biochemical sedimentary rocks. That's all for me. Next reporter. Thank you.
Metamorphic rocks. So this is the illustration of the origin of rocks. Metamorphic rocks, two types of metamorphism. The first one is contact metamorphism. Changes due to increase in temperature where rocks come in contact with heat source. For example, magma chamber. Example is limestone around a magma chamber is baked by heat to form marble. Marble and limestone have similar composition, but marble typically has a larger grain size. The second types of metamorphism is the regional metamorphism. Increased heat and pressure associated with plate tectonic processes that form mountains. Increased pressure and temperature cause tabular minerals to take on a preferred orientation, foliation perpendicular to direction of pressure. So foliation is produced when tabular minerals grow perpendicular to the direction of pressure. Metamorphic rocks. Metamorphic rocks are the result of transformation of a pre-existing rock type, the protolith, in a process called metamorphism, which means change in form. The protolith is subjected to heat greater than 150 degrees Celsius and or extreme pressure causing profound physical and or chemical change. The protolith may be sedimentary rock, igneous rock, or another older metamorphic rock. Texture. There are two types of rock's texture. The first one is foliated. Foliation refers to flat or wavy planar features looking like layers caused by the alignment of platey minerals such as mica. Foliation may also look like alternating bands of light and dark minerals. The second rock's texture is non-foliated. Non-foliated rocks have interlocking grains with no specific pattern. They are classified based on composition, and this usually depends on the type of rock it originally formed from. Homogeneous. One of the types of homogeneous rocks are the quartz, and this is how it looks like. Characteristics: chemical composition. Sulfur with a chemical symbol of S. Quartz, silicon oxide, and tourmaline. Ordered atomic structure: nesosilicates, silicon oxide with 4 atoms, sorosilicates, silicon oxide with silicon with 2 atoms, and oxygen with 7 atoms. Chemical classification: acid igneous rocks containing a high silica content greater than 63% silicon oxide. Intermediate igneous rocks containing between 52 to 63% silicon oxide. Basic igneous rocks have low silica, 45 to 52%, and typically high iron, magnesium content. Ultra basic igneous rocks with less than 45% silica.